Hello, AP Macro teachers. Hopefully the beginning of the semester is going well for you. Today I want to put up a video talking a little bit about a couple of different things with regards to the production possibilities frontier. So this is generally my second lesson about the production possibilities frontier that I do with the kids. And this is also one that tends to take quite a while. So this is a place where the kids generally have difficulty, especially your kids who are a little bit weaker in math. They tend to struggle here and they're going to need a little bit of extra help. So hopefully we can kind of do a brief run through on this. That way you are ready to help them and answer any questions. I am also going to cover towards the end of this video something that the kids need to know for the AP exam that the textbook doesn't cover at all, and that would be setting the terms of trade. So this is going to be a bit of a lengthy video, but please stick with me if this is something that you're interested in or something you're not 100% on. The first slide, we're going to talk about calculating opportunity costs and the different types of production possibility frontier they'll see on the AP exam. The second slide, we're going to run through finding comparative advantage and absolute advantage and what to do with that information. And then we'll wrap it up with the third slide, which is setting the terms of trade. So if you already know how to do what's on slide 1 and 2 and just want to run through on terms of trade, since the textbook doesn't do a good job of that at all, go ahead and skip to the part of the video where I switch to the third slide. Thank you very much. So the first thing we're going to look at today is how to calculate opportunity costs kind of in general. And one of the things that confuses the students is that the Krugman textbook gives two different versions of the production possibility frontier. One which shows the law of increasing opportunity costs, which is the one on the left-hand side here, and the other where the production possibility frontier is presumed to have a consistent slope. Now we know, and at this point the kids should know, that the production possibility frontier doesn't have a consistent slope because opportunity cost changes over time due to the law of increasing opportunity costs. But for the sake of simplicity, the AP exam generally asks the kids questions about the PPF using a production possibility frontier that's simplified to a consistent slope. So what I want to do here is talk very briefly about each of those and how to use them, keeping in mind that it's number 2 that the kids really need to be familiar with. I'm going to go over one a little bit just because it's in the book and it's something that the kids will see questions about out of the Krugman test bank, but in general, it's number 2 that the kids need to know like the back of their hand. So for the version of the production possibility frontier that shows increasing opportunity cost, the line doesn't have a consistent slope, which means all of the slope calculation that we're going to do for figuring out opportunity cost is going to have to be done from one section of the line to another, meaning that we need a start point and an end point in the line, and we can figure out the slope for that specific section, though we can't figure out a general slope for the entire curve as it changes over time. So what you see me having here, I'm going to go ahead for the purpose of this video and use the numbers out of the Krugman textbook because those are the numbers the kids are going to see. But certainly if you want to change it up or come up with your own numbers, just shoot me an email and I'll be happy to help you with that as well. So taking a look at the line with increasing opportunity costs in our imaginary scenario over here, we've got point A and point B, and we're being asked to calculate the slope of the line to basically find opportunity cost between point A and point B. In order to figure this out, I'm basically going to need to figure out fish to coconuts and coconuts to fish and kind of calculate those ratios. It's really, really simple. The easy way to remember it is whichever of the two variables you want to equal 1 goes on the bottom of the fraction. So it's basically the thing that you divide by. So if I'm trying to figure out, let's say that y was coconuts, which it is in the book, if I'm trying to figure out 1 coconut is equal to some number of fish, the formula for that is 1y, with y being coconuts, is equal to change in x over change in y. And that should give me the appropriate ratio. When having the kids do this, I always make them give me the answer here in a decimal because I found that if they give me a fraction, it tends to confuse them a little bit. So even if they come up with a fraction as an answer, I make them turn it into a decimal for me. If I was trying to find the ratio of fish to coconuts, if fish is on your x-axis, then it would be 1x is equal to change in y over change in x. Now, it's nice for the kids to know how to do this just because it helps them to kind of solidify their understanding of increasing opportunity cost. But in reality, especially for the FRQ portion, the AP exam doesn't actually ask them to do it this way. So while knowing this is nice, I wouldn't necessarily pull teeth making sure that they knew how to do it backwards and forwards, as it is not likely something that they're going to be asked to do on the AP exam. What they definitely need to be able to do is calculate opportunity cost for the production possibility frontier on the right, which has a consistent slope all the way through. And this is done essentially the same way. So it's 1y is equal to x over y, and 1x is equal to y over x. So in this scenario, it would be 40 over 30 and 30 over 40 respectively. What the kids will need to be able to do, especially when we move on to the next portion, is make sure that they understand what the trade-off relationship here is. So how many fish do they have to give up for each coconut gathered? How many coconuts do they need to give up for each fish gathered? But it's a relatively simple thing for the kids, especially kids who are strong at math at all, to be able to do. I have noticed, especially if you've got some of the Cal BC kids, they tend to want to make this a lot more complicated than it absolutely is. So they'll show up and they'll be like, oh, I want to take the derivative of that line. I generally shut that down in my class just because it confuses most of the other students. And it's one of those scenarios where too much information can actually be harmful. But certainly I'm happy to let them do it themselves, but it's not something that I necessarily want to cover in class at all. Moving on to the next slide. So once we know how to calculate opportunity costs, the next thing the kids are going to be asked to do is to take that information of calculation of opportunity costs and apply it to a couple of scenarios in order to find absolute advantage, comparative advantage, and then once we have comparative advantage, we're able to move into specialization and trade. The first thing that the kids will be asked to do is they're given the Tom and Hank graphs, which you see here. And it's really easy to do without even doing any math, is they can find absolute advantage. So we can figure out who has absolute advantage in the production of a product if they can produce more of that product than anybody else with the same resources. Given our simplified Tom and Hank economy in the textbook, the only resource Tom and Hank are using up really is time. And so given that they have a set amount of time, we can tell really easily who has comparative advantage in coconuts. So we see that given this set amount of time, Tom can produce 30 coconuts, whereas Hank can only produce 20, meaning that since Tom can produce more, Tom has absolute advantage in the production of coconuts. He's just objectively better at gathering coconuts than Hank is. We can see that given a set amount of time, Tom can produce 40 fish in the amount of, or with the same amount of time, Hank can only produce 10, meaning that Tom also has absolute advantage in the production of fish. So Tom has absolute advantage in production of both of those products, which kind of puts him in the position, if we were to make this into a real-world scenario, of the United States. The United States is a highly productive nation. Our workers are basically second to none when it comes to productivity, and we can produce more of almost anything we put our minds to than any other country. We have absolute advantage. The key thing the kids are going to have to realize here, however, is that absolute advantage doesn't actually matter as much as you would probably think it would. Being better at producing something isn't what determines profitability, and it isn't what determines gains from trade. So while knowing who has absolute advantage is certainly nice, it's not really the relevant piece of information here. It's comparative advantage that we actually care about, and in order to solve for comparative advantage, we need to figure out the relative costs of fish and coconuts that Tom and Hank incur. So let's go ahead and do a real quick run through on that math and figure out what to do with that math once we already have it. So we're going to go ahead and and jump over to the right-hand side of our page here to calculate the opportunity cost of fish and coconuts for Tom and Hank. So over here, taking a look at Tom's graph, it's really easy since we're using the version of the graph that has a consistent slope. If we're trying to figure out how many coconuts each fish costs him, we're going to solve for fish, meaning that fish goes on the bottom. So it's going to be one fish is equal to 30 over 40 coconuts, which is going to give us a cost of 0.75 coconuts per fish. And to figure out the cost of a coconut, we're going to do the opposite. So it's going to be 40 over 30, giving us 1.33 fish. We're going to do the same thing over here for Hank, and then we're going to be able to compare the relative costs of each other. So skipping over the math here for you, we see that for Hank, one fish cost him 2 coconuts and one coconut cost him half a fish. Now, the students are probably going to be surprised by what happens here. Because Hank is so bad at fishing, gathering coconuts doesn't actually cost him all that much in the way of fish. Now that we have these relative ratios, all we have to do is compare each one to figure out who produces a product at a lower cost. So if I'm trying to figure out comparative advantage for fish, I see that Tom produces fish at 0.75 coconut cost. Hank produces fish at 2 coconuts cost, giving Tom comparative advantage in fish. Taking a look at coconuts, I see that a coconut costs Tom 1.33 fish, whereas a coconut only costs Hank half a fish because Hank was so bad at fishing he wasn't giving up all that much, meaning that in this scenario, Hank actually has comparative advantage in the production of coconuts. Now that we know who has comparative advantage in fish and who has comparative advantage in coconuts, we can then move on to a trade scenario where Tom and Hank can enter into mutually beneficial trade where they both end up with more things than they began with. This is the process called gains from trade, and that's going to be the thing that we show you how to do on the next page. So at this point, once we figured out comparative advantage for Tom and Hank, we can then transition into figuring out gains from trade, and then finally wrapping up the lesson by figuring out how to set the terms of trade and how to know whether or not trade is beneficial to both parties. So, in order for trade to be beneficial, in order for both parties to end up ahead, we need to first accomplish specialization. So in this scenario, Tom and Hank are going to specialize in whatever they have comparative advantage in. In this case, Tom had comparative advantage in fish, so he's going to produce only fish. He's going to make 40 fish, which is his maximum. Hank has comparative advantage in production of coconuts. He's going to make only coconuts, giving him a total of 20 coconuts, and they are now going to trade with each other for the item that they don't produce. Keeping in mind they both need fish and they both need coconuts, so after specialization, they're going to be dependent on each other, which, as we talk about in economics, actually isn't necessarily a bad thing, as dependence and trade tends to lead to more peaceful existence or coexistence amongst nations. So this is the type of scenario that plays out on a global scale as well. At this point, I usually like to talk to the kids about what the United States has comparative advantage in and what are some of the things that we produce versus the things we don't. Because if you ask the kids, what do we produce in the United States, the most common answer I get back from them is nothing. They have this belief that we're actually not a productive nation or that we're a nation on decline. We are by far the most productive nation on the planet. We trade a whole lot. We do certainly purchase more from other nations than they purchase from us, but we do produce a lot of things here. It's just not the same things that we used to. So I usually transition this, although this isn't on the AP exam, into a brief discussion of what types of products the United States does produce, specifically things like pharmaceuticals, intellectual property, agriculture, weaponry, and complex machinery like airplanes and submarines and CAT scan machines. And those aren't things the kids usually interact with. Certainly they can tell you what we import. We import textiles and we import labor-intensive manufactured goods and pretty much everything else. But I do like to point out to the kids that we do produce a lot of products in the United States, and they're much higher value products. Sure, we don't make blue jeans in the United States anymore, but we still make airplanes and much more high value, high skill jobs. So when it comes to finding terms of trade for Tom and Hank, it's actually relatively easy. In order to figure out what terms each of them are willing to accept when it comes to trade, we have to look back at the ratio of the trade-off between fish and coconuts that they were getting before they specialized. So we can see in this scenario that when he was doing fish and coconuts, he was producing fish and coconuts by himself. Tom had a trade-off of 1 fish for 0.75 coconuts. This means that Tom is going to be agreeable to any trade-off relationship with Hank that results in him getting more than 3/4 of a coconut for each fish that he gives up. On the other side, we can see that since Hank is specialized in coconuts, prior to his specialization, he was getting half a fish trade-off for each coconut, meaning that Hank is going to be willing to enter into any trade agreement that gets him more than half a fish for each of the coconuts that he gives to Tom. So the question that the book poses then is, are they both willing to engage in trade if 1 fish is equal to 1 coconut? Is it fair to do just a 1-to-1 trade-off of them both? And the answer to that is absolutely yes. So we can see that for Tom, getting 1 full coconut for each fish that he gives up is giving him an additional 0.25 coconuts over what he would have been getting on his own. And for Hank, getting a full fish for each coconut that he gives up is getting him a bonus of an additional half fish for every coconut that he trades. So on the last slide, we're going to go ahead and just presume that they trade 10 fish for 10 coconuts. We're going to quantify that and make sure that there are actually gains from trade, which there are, and that'll be the end of this lesson. So the last thing that we need to do for this lesson is just line up where Tom and Hank were before specialization in trade, compare that to where they are after specialization in trade, and to make sure that they are both better off. Because remember, 2 parties will only engage in trade if they both end up better off than they were before. So we can see here that before the trade happened, Tom was producing 28 fish and 9 coconuts. Hank was producing and consuming 6 fish and 8 coconuts. If Tom specializes and produces 40 fish and 0 coconuts and gives 10 to Hank, he will end up being able to consume 30 fish and 10 coconuts, giving him a benefit of 2 fish and 1 coconut above doing it all on his own. Hank will produce 0 fish and 20 coconuts. If he gives 10 of those coconuts to Tom, he'll be able to consume 10 fish and 10 coconuts, giving him a benefit of plus 4 fish and plus 2 coconuts over what he would have been able to do by himself. Now, one thing the kids like to point out here is that they don't benefit equally from trade, and that's absolutely true. There's no rule that says that the trade has to be equal. In this case, Hank is clearly benefiting more as a percentage than Tom is, but that doesn't really matter to whether or not the trade's going to occur. Tom doesn't care how much Hank is benefiting. Tom's not really interested in Hank. He's only interested in himself. And if you provide Tom with a scenario where he can end up with more fish and more coconuts than he had before, he's certainly going to take that opportunity, regardless of whether Hank ends up slightly better off in the trade than he does. Everybody benefits, so everybody is going to engage in trade. I know this was a long video. I appreciate you guys sticking with me. Hopefully you find this helpful. In total, this lesson in some years takes me 2 48-minute class periods. In other years, it's taken me 3. I think the key to making sure the kids understand this is to give them ample practice at each step along the way. So make sure they know how to calculate opportunity cost. Make sure they can find comparative and absolute advantage. Make sure that they can find the terms of trade, and then make sure that they can prove that those terms of trade actually bear out. This is a lot of stuff. The kids are going to give you a little bit of resistance because a lot of times they don't like math, but this is a skill that's going to be used later, so just make sure that they know how to do it. Give them a little extra time than you normally would, because it does take them a little while to process all this and to get enough practice to do well. Shoot me an email if you've got any questions, comments, concerns about any of this. If not, have a great rest of the week.